Hey, what's going on, guys? Kikins here. In this video we're going to be handling capture moves. So the basic idea is very simple. We need to loop over the bit boards of the opposite side of the side that is opposite to the side to move. So say it's white to move, then we need to loop over all the black bit boards, and if there is a piece on some of then we'll need to just be getting the bit on every bit board from the opposite side, and in case if the bit would be where the target square is, we will need to reset it. So the idea is very simple. We just first we only move the pieces, right? But if we move the problem is that if we have 2-bit boards, then we have this source square and the target square, but for white pawns we just move it right over in here, but black piece that was captured, it's not disappearing. So our goal is to make that black piece getting disappeared, and that's kind of pretty easy. So it's again like much easier to show and implement rather than to explain. So without further ado, let's actually start writing some code. So here we would be handling capture moves. So we can simply say if get move capture, and move is an argument. So if this expression gives us true, that means that the current given move is actually capturing something. And now we need to pick up bitboard ranges depending on site. So pick up bitboard piece indices or piece index ranges depending on site. And what I say by saying that, what I mean by saying this, so let's first define a couple variables. So it would be the start piece, and this would serve as an index to index the opponent's opposite bit boards. So start piece and end piece as well. And now we can actually say if site is equal to white, so like white to move here. In this case, we gonna set up this start and end piece the following way. So the start piece would start with black pawn, and the end piece would end with black king. And otherwise, so here if we have black to move, then we need to say else, and respectively start piece would be equal to white pawn, and end piece would be equal to white king. And now we need to loop over over bit boards opposite to the current side to move. Well, I hope this makes at least some sense. So we can say for, and let's create the integer called bitboard piece equals start piece. So again, like well, let me just first implement this, and then I'll try to explain. So bitboard piece is less than less equals, this is important, than end piece, and bitboard piece plus plus. And so the idea here is very simple. Let's say we have white to move. Let's say white pawn is capturing something, and we have the side is equal to white, and we're setting up the start piece and end piece to the range to the indices representing the range of the bit boards for black bit boards. So assuming this piece code, so we just have a look at the piece codes again. So this is the range for the black pieces, and this is the range for the white pieces. So starting from here and ending up right over in here. So let's get back to our make move now. And we just loop over all the bit boards, over the indices for the opposite side bit boards, and here we just need to track whether is there a piece on the opponent's bit board. So we can simply say like if get bit and bit boards indexed by bitboard piece, then we simply need to say pop bit and bitboards indexed by bitboard piece. So whatever bit we find there, we just pop it. And yeah, by the way, obviously add the target square. Yeah, obviously add the target square, otherwise it won't be working actually. Okay, and the same, just getting rid of this on the target square as well. And also, as far as we can have only one square, only one piece on one given square, we can also break out of this for loop immediately when we hit this sort of a condition. So if there is a piece on the target square, we just remove it from corresponding bitboard. That's it. And just break out of the loop, because we don't have any that's impossible to have multiple pieces on the single square. Okay, and also let's actually give another curly braces pair here, and let's try to compile and run this to make sure no typos or any errors. Okay, so make debug, and if it makes, just want to run the BBC binary executable here, and it compiles and runs perfect. And if I did everything correctly, it now should be capturing the pawns. Okay, so now it captures the pawn. You see, like the black pawn has been erased, and yeah, so we just now have all the captures being handled. See, like knight is capturing here. So now all the captures are being handled correctly. And to give you an idea, to give you even a better idea of how this works, I would like to print some bitboards instead of the board here. So let me just try to print bitboard. Try to print the bitboard and bitboards. Well, we could have actually get the current piece from the move, and probably let's do it actually. So get move piece from the move, like this. And also, so first I just want to show you how it works for those pieces that are actually moving, and then I'll show you what happens to the captured pieces. So let's make sure to save and run again. So you see, like now we're moving the white pawn. So here we see the white pawn bitboards, and now it goes to knights. See, like now it's moving the white knights. So it's just switching the bitboard depending on what piece to move is now we have, and so on. So I hope this is quite pretty clear. And now, so I just don't really want to have this anymore, and I will probably, well, or let's actually, I'm not exactly sure how to automate this process, to be honest. Okay, let's just I just want to have a look. So probably, so what do we capture? So we're capturing black pawns mostly, yeah? Well, there would be a case when we would be capturing this white, this black bishop, but doesn't matter. So let's have a look at the black pawns bitboard. So we just print the bitboards for black pawn here and here every time we're making our move. So let's have a look. So now it goes to d5 goes to e6, nothing happens, but now we capture, and so this is the black pawn's bitboard. Now it disappears. Now we move in the pawns until it would capture here, okay? And now it would be capturing this and this one. So here, here, and here. Well, not at once, but still. So you see, like, black pawns are disappearing along the way when they are getting captured. So that's the core idea behind handling the capture. So we need to make sure that we are raising the bit from the bit board where the piece has been captured. Well, maybe not the best ever implementation ever, but still, at least it's quite pretty self-explanatory, I hope. And I hope it's kind of clear, like, what's going on within the source code. Well, okay guys, so this is it from my side. I hope you learned something interesting out of this video. Thanks for watching. I hope to see you in the next parts within this series. Until the next time, and take care.